Welcome students to this screencast, and we're going to talk about the strength of shapes and the importance of different shapes in architecture and construction. This is an introduction leading into our activity that we'll be doing in class on Friday. I got this PowerPoint from a nice website over at teachengineering.org. If you're ever interested in looking up engineering information, I encourage you to go there. A lot of cool resources available for you as well as for myself that we'll be using in class. Alright, so going on and looking at a couple pictures, I want you to just think about the type of shapes that you notice in these bridges. And hopefully you notice a lot of familiar shapes. You might even notice some things that maybe haven't been defined in previous math classes. In fact, this shape right here is something you will probably study a ton more, and I apologize for my bad writing there, but you'll study that a lot more in high school. But that right there is called a parabola, and you may or may not have seen one of those before. And again, so we saw bridges. Here are some buildings. Hopefully you're seeing some similarities between the different types of structures. In here, you see some shapes and other things like a motorcycle, an instrument used, what I think used in space, a crane, and then also a roller coaster. So hopefully those are some familiar things you've seen before. But on your paper, go ahead and do this little exercise. Pause the video and draw these shapes, and then draw what you think would happen if you were to apply force at the green arrows. So pause the video, take a minute to draw the shapes, and then draw what they would look like if we applied forces from the top down here, like this. All right, hopefully you've drawn your shapes and drawn your predictions. And hopefully you'll be able to tell me Friday that yours were similar to what you see down here. When we apply these forces like this, notice how the angles change in this quadrilateral. We started out with what looked to be a square, and now we're left with what would be a rhombus. All right, so a quadrilateral with equal sides, okay, parallelogram with equal sides, but the angles are not necessarily congruent, or all the angles are not congruent, so therefore it's not a square in this case. This is a rhombus. Notice same thing going on here, but notice what about the triangle? What happened? Even though we applied force, it seems that the angles are still fixed. Turns out that the triangle is the only shape that wouldn't collapse in this situation. The other ones collapse when we apply this force because the structural members did not change, but the angles change. Okay, the angles between those structural members changed. Triangles do not collapse because the angles are fixed and they're based upon the lengths of the opposite sides. And in fact, when you get into high school, there are some special relationships between angles and their opposite sides, and you'll learn about that. There's one called the law of sines, so that's a high school piece there, and we may even mention it in our class this year. And there's also something called the law of cosines. It helps define these relationships between the angles and the opposite side lengths of a triangle. So interesting stuff, because when it comes to architecture and construction, triangles are very important. In fact, pretty much all polygons will deform, if you will, when we apply different types of forces to their sides. Everything except the triangle. Right? The triangle does not collapse. So neat thing is we can take these other polygons, and if we create triangles, like here in this quadrilateral, which looks to be a square, we can draw a diagonal and create two triangles. We can take this pentagon and draw two diagonals here and create some triangles. And then we can take this hexagon and we can also draw these diagonals, okay, connecting one vertex to a vertex on the opposite side of the figure, and we come up with these different triangles, which add a lot more strength and structure to our shapes that will prevent them from collapsing. Notice it will also apply in 3D. If we were to apply pressure to the top of this cube, it would actually start to buckle and bend. And in fact, if we were to build something like this in class using our materials, you would notice that you would be able to literally flatten out this cube if it would give you that much flexibility. Otherwise, these sides here would just break. But if we create triangles, okay, or these triangular pyramids, here we've got a square pyramid, square base, and then we have triangular based pyramids here. These provide a lot more strength to our structures. And often when we do this, we call these trusses. All right, when we add these triangular pieces, these triangular geometric shapes to our three-dimensional geometric shapes. So I want to go back and just show you for a second, go over a little bit of vocabulary. I know that was a quick review. Feel free to look over the video again if we went too fast. But I do want to come down here and look at a little vocab. Notice we're applying this force that forces these quadrilaterals or these polygons to buckle and collapse. We call that compression. So I just want you to know what that is. If I mention this in class, you'll know that compression, that's a squishing force, a force that causes these shapes to buckle. Parabola, we talked about that earlier, giving you a little heads up on high school. And then racking, that's the process of a shape collapsing from a regular polygon into an irregular polygon. So when a polygon has all sides and all angles congruent, we call that a regular polygon. And you can see that right here, regular polygon, polygon that is equilateral, sides of equal length, and equiangular, meaning all the interior angles are equal. But racking is that process of forcing that geometric shape to collapse or to go into an irregular polygon. All right, and then scaffolding and truss, these are ways, scaffolding is a way that construction workers reach tall heights, but a truss is what I was talking about there towards the end, and that's where we use triangular elements to strengthen our three-dimensional structure. So notice here, racking, causing this to compress if we apply compression from the top down. Here we build these trusses that give a ton more strength to our three-dimensional structures. Hopefully you'll watch this. This will give you some ideas about how to build your structures in class tomorrow. See you then, and thanks for watching.